Hello, everyone. Welcome to this webinar on the uses and benefits of developing high-performance computing in Mexico. My name is Hermann Vasconcelos. I'm the ambassador of the Energy, R&D, and Innovation Funds run by the Ministry of Energy of Mexico. And it's my pleasure to be here with all of you. First of all, I want to thank our host here at Lawrence Berkeley National Lab, and particularly Dr. Horst, the Deputy Director and Chief Research Officer of the lab, as well as Alberto Diaz, Program Manager of the Mexico Energy Initiative at Lawrence Berkeley. Today, before we get started, a few announcements for you to know. This meeting is being recorded, and we will be sharing a link. So everybody can please circulate it and share it with your contacts. Each panelist will speak for 5 minutes each, and then we'll go to a Q&A session for a total of 60 minutes. We'll actually finish at 9:55. Please submit all your questions through the chat feature that you should see on your screen, and we will address some of your questions and try to get back to the questions that we don't get to. So it's my pleasure again to be here with a group of very distinguished leaders in the energy sector, both on the energy policy side as well as energy research, and of course in high-performance computing and supercomputing. The order will be the following: Carlos Ortiz, the General Director for Energy, for R&D, Research and Development, Workforce Development at the Ministry of Energy of Mexico, known as NERSC, will start giving us the vision and on this initiative on high-performance computing and supercomputing in Mexico. We will then continue with Dr. Horst, again, Deputy Director and Chief Research Officer at Lawrence Berkeley National Lab. He will share his experience and lessons learned developing this type of centers here in the U.S. and his lessons learned around the world. You should know Horst is a pioneer in supercomputing, so it's really exciting to hear from him. Then we will continue with David Skinner. David is the lead for strategic partnerships at the Supercomputing Lab here at Lawrence Berkeley. He will share his thoughts on the benefits of this type of tools and the opportunities and lessons he has learned from collaboration in this space. And then last but not least, we will hear from Dr. Jeff Roberts. Jeff is the director of the Advanced Technologies in Lawrence Livermore Lab, the National Lab at Lawrence Livermore, and very importantly, he launched the HPC for Manufacturing program with the DOE, so high performance computing for manufacturing. So we will hear from Jeff on the benefits for industry and some specific case studies or examples on that. So without further ado, it's my honor to give the floor to Carlos Ortiz, again from the Ministry of Energy of Mexico. Carlos?
Okay. Thank you so much, Hermann, for the introduction, and thank you, Horst, Alberto, to everyone for hosting this workshop. I will be making a brief presentation on the concept that we are under the process of developing of a national energy supercomputing center for Mexico. I'll cover 3 topics in my presentation today. One is the background. Second is what and why do we want to develop a national supercomputing center? And the third one, how do we plan to get there? In the front of the background, I just want to briefly share that my office within the Secretary of Energy, which is the homologue to the Department of Energy in the US, is the Office of Science and Talent Development. So what we do is we conduct the research and talent development policy for the energy sector, and we focus on 3 key activities. We develop talent. We are the 2nd largest scholarship grantor in Mexico. We have around 3,000 scholars around the world in energy programs, master's, doctorate, postdoctorate. We do a lot of work on capacity building with Mexican institutions to develop the capabilities that they need to train and research the priority areas in the energy sector. And we also promote research, development, and deployment through several programs and projects that we finance. Why do we want to work on a national supercomputing center? First off, I want to say that some of you might know that we recently, as a country, approved an energy reform, and this energy reform changes completely the rules of the game. Before the energy reform, the energy sector in Mexico was solely operated by two monopolies, two state-owned companies. So for the oil and gas sector, Pemex, and for the electric sector, CFE. These no longer exist. Now we have a completely open market energy sector throughout the entire value chain, and this changes drastically the rules of the game. The second reason is we aim to store and process data that is of national interest in a supercomputing center. What we're looking at in the bottom left side of the screen is a little video of, just to give you an example of what I'm referring to, on the seismic data obtained throughout 2015. When the video started, we were at the beginning of the year 2015, and as we progress, we'll see everything that was done throughout the year. This is all raw seismic data, and what the regulation says is that this seismic data is produced by private companies, and the regulation mandates that the private companies have privilege to maintain this data for a period of 5 years and share with the government from year zero. What the regulation doesn't say is what happens with the processing of this data. So any derivatives of the data, companies are not obligated to share with the Mexican state. So as you can imagine, there can be a large asymmetry of information once companies start processing this data, understanding the oil prospection to a much deeper level of understanding than the government, and this is a situation we want to work on. But on top of that, that's just an example of data that is of national interest to be stored and processed. But there's also the objectives of promoting research and innovation in the energy sector. To give you an example, as a country, we're leading the materials discovery challenge within mission innovation. And one of the key elements on this challenge is simulating materials for energy application. And that, of course, requires supercomputing processing power. So those type of projects that we believe that can provide tools to industry and scientific community to go further that are not currently existing in Mexico. The way we're thinking about a supercomputing center, very briefly, is not as a step function where we go from not having a energy supercomputing center to having it, but more as a roadmap. Where do we want to get, and how will we get there? So we're focusing on understanding the types of facilities and equipment that we need, the type of location, network, computer architecture, the scalability, the adaptability, the type of applications that we want to work on. So for example, I just mentioned the seismic processing, the materials, but we've held workshops where we've identified up to 25 different applications at the moment that are of relevance to the Mexican energy sector. Also, guarantee that the center can be open to competitive access and also to industry collaboration. We'll be hearing from Jeff Roberts how that can be a very relevant use of a supercomputing center. And obviously, an additional element is the talent, not only from operations and programming of the facilities and the machine, but also in terms of the researchers and the users, government, academia, industry. So the way we're seeing this is setting up a roadmap where we work on all of these elements, making sure that there's a delicate balance amongst all elements so we can reach to a point where we have a robust operating and successful supercomputing center. The center would be operated as a laboratory of the three national institutions that we see in this slide: the Nuclear Research Institution, the Clean Energy Institution, and the Mexican Petroleum Institute. These three are national labs addressing different needs of the energy sector, and they're all ascribed to the Secretary of Energy. So this would be at its heart a project and a laboratory of the Secretary of Energy and its national labs. How do we get there? The early concept began in 2016 when we started seeing the need for something like this. And we've taken some key steps to make sure that we get there on a healthy fashion. We recently signed an MOU with Mateo Valero from the Barcelona Supercomputing Center to have support throughout the process. We've held application workshops to understand the type of applications that we can work here. We recently approved a training program of around $4 million to train people on all aspects of supercomputing to make sure that we have the talent. Today, we're holding this webinar where we're sharing this idea with you. On September 12th, we'll be having a road mapping workshop to develop this roadmap. We're bringing all stakeholders around the country, and we're honored to be joined by Mateo Valero, Horst, and Jeff Roberts, and several experts that will help us understand and develop a roadmap to get there. Also, I didn't mention it here, but we also signed an MOU with the University of California System and LBNL, not specific to supercomputing, so it doesn't show here, but we're also leveraging it to help us get there. We expect to publish this roadmap by the end of the year, and then 2018 and beyond, we would be seeing all these activities to have a CFP for the machine, facilities, and so on. One thing that I want to mention last is that we're not starting from scratch. We are leveraging existing efforts that exist in Mexico. There's a large group of people that have been working on supercomputing in Mexico, and we're looking forward to bring all their expertise into the equation. So that's my presentation for today. Thank you.
Thank you very much, Carlos. That's really exciting to hear about this initiative in Mexico. Let me just emphasize that the speakers in this panel will be joining us in Mexico City for that workshop on September 12th, which is part of a larger energy summit that led by the Ministry of Energy of Mexico and the government of Mexico. And so this is excellent. So next, we will hear from a pioneer on all these topics, Dr. Horst, again from the Lawrence Berkeley National Lab. Horst, thank you very much.
Thank you, Hermann and Carlos. Good morning. It is a great pleasure for me to be here and participate not just in this webinar, but with my colleagues in Mexico to advance the concept of supercomputing in Mexico. I've been in this field for 35 years now, since the early 80s, and been in this field in all aspects, as a user, as an algorithm application developer, as a center director, and now at the current part of my career, actually, I'm looking back and find it very exciting to, in a sense, go through the cycle one more time and see in a country like Mexico to actually help building a supercomputing center. It is very important to keep two things in mind. One is the role of California, in particular the University of California. As Hermann already and Carlos mentioned, we have an agreement between the University of California and Mexico about collaborating in the field of energy. It's part of the President's initiative, the University of California President's initiative to bring UC and Mexico closer together. So in that space, it is important to note that the University of California is actually one of the largest world powers almost in supercomputing. It manages the national labs at Los Alamos, at Livermore, and in Berkeley, and it has a large facility at UC San Diego. All these sites together run very large supercomputing operations. So from a computing point of view, the University of California is one important, maybe the most important partner also in high-performance computing, not just in the energy sector. The other part, and I'm very pleased to say this, is that there's the opportunity of collaborating between CNER, and the Department of Energy centers that are represented here from Livermore and from Berkeley. And just like CNER now, DOE has for many years, since the early 70s to now, continued to support high-performance computing as an absolutely essential part of the mission-driven research that DOE is engaging in. You will hear from Larry Roberts and from David Skinner, from Jeff Roberts and David Skinner, later on several examples on how supercomputing is helped specifically for the energy mission. But the national centers are more important because the national centers create also an ecosystem of innovation. And this ecosystem of innovation that has been promoted through the supercomputing centers in the US includes outreach to universities, training of students, making them computationally more knowledgeable, changing the science, supporting computational science, and as Carlos correctly pointed out, more recently, supporting big data, and on top of big data, also supporting new activities such as machine learning. The fact that these ecosystems are extremely important can be shown through some, maybe in hindsight, serendipitous discoveries, but if you go back and look at, for example, the Mosaic web browser, which opened up the World Wide Web to mass use in the early 90s, was discovered at a supercomputing center. And I think for a country like Mexico that continues to develop its technical and scientific capabilities, it is important to catch up in high-performance computing because it will create an element of the scientific ecosystem that is currently missing in Mexico. So it is not just for the industrial applications, for efficiency in the energy sector, but for the national well-being to improve the computational infrastructure. And with all of this, I'm very happy to be involved in this conversation with colleagues in Mexico and help them building such a center.
Thank you very much, Horst, and thank you for your partnership. It's really a pleasure and honor and great value added for Mexico to have the opportunity to collaborate with Lawrence Berkeley and with such distinguished experts. Before we go to David Skinner, I just want to emphasize what Horst pointed out, which is the role of California, and I want to again thank and highlight the fact that we signed here at Lawrence Berkeley this MOU with the University of California system at Lawrence Berkeley National Lab with President Napolitano and Deputy Minister Leonardo Beltran back in October 2014. And we also have an agreement with the California Energy Commission and with the office, with Governor Brown actually, who signed an MOU with the Minister of Energy of Mexico, Pedro Joaquin Caldwell, in July 2014. So California is central to this effort. We appreciate, again, the willingness to partner with us, and we really look forward to making this happen and benefiting California, Mexico, the U.S., Mexico, and the world. So on that, please, David Skinner, thank you very much for being here.
Sure. My name is David.
You have some slides, right, to share.
I do. I'll just talk a little bit before the slides go up. My name is David Skinner. I work here at Lawrence Berkeley Lab, and not for 35 years like Horst, but for several years have enjoyed computing for all the reasons that Horst just mentioned. My presentation will do a little bit deeper, more specific dives into some use cases. I think really what this is about is communicating what the value proposition around HPC is. As the slides come up, I think I would also like to thank Hermann for setting this up. Me alegra mucho estar aquí con ustedes y hablar en computación y HPC. There's a lot of interesting things in HPC that we could talk about, and not in 5 minutes, but here's a few. So I put up two pictures here. One is sort of a signpost of past and future, because in talking about uses and benefits of HPC, I think it's important that we think about what are today's needs, and as opposed to things that HPC might have meant in years past. And below is a nice colorful picture of our current amazing machine, Cori, which I could talk a lot about, but we'll just show the picture. Use this? Okay. So 6 quick points here. One is that, and I think all of these are not controversial, HPC is expanding from the realm of scientific discovery to the factory power plant shop floor. I think this is a ramification in some ways of Moore's law and concurrency, but HPC is spreading for sure. HPC models of energy systems can reveal cost savings and deliver confidence in design changes. So this is a particularly valuable aspect in clean energy technology deployment. Thirdly, HPC is not just simulation, it's also data analytics at scales where massive computation comes into play. Sensor networks, as Carlos mentioned, from data being measured out in the field and brought together to form models. It's also used in the operation of energy systems where sensors can tell you how to run the device concurrently with a model. Fourthly, that the HPC application space is growing. It's been growing for a long time, but I think the growth is quite clear across the board now that we see high performance computing being used in a really growing variety of examples. And I'll provide one here, which is from the paper mill and paper pulping area. HPC software is something that I think is worth meditating on quite a lot, because there's a lot of software out there. It can be repurposed in different ways. Oftentimes, HPC collaboration can start with software because it's easy to get involved in. And lastly, that HPC algorithms can really change the way that scientists or other stakeholders think about what computing is doing for them. And the two examples in Carlos's presentation were bringing together data from oil and subsurface, and the other is in materials discovery. And this is really what I mean more here, is that by using enough computing, we can really change the model for how people think about materials discovery and how they think about their field of study. The one example that I really wanted to try to get across here is the use of a code called Chombo Crunch by David Tribukait and Hao that is part of this HPC for manufacturing program that Jeff helped set up and that we'll hear more about. The value proposition here is that making wet paper dry costs a lot of energy. You can read a little bit about that up in the upper left. By bringing together people, software, and HPC systems in the blue box in the lower left, they're able to tackle this important problem in the re-wetting of paper. Basically, that as paper is pressed dry, the water creeps back into it, and if that didn't happen, a lot of money could be saved. So the approach to this is to use an adaptive mesh refinement code that's quite generally repurposable for the specific case of pushing water out of paper. And in doing this, they were able to, first of all, see what's going on, and second, I'll make a useful reduced order model that could be used by the consortium of paper manufacturers who are tackling this problem. So I think this is an example of HPC expanding into a space where oftentimes it wouldn't be seen before and can be quite powerful. A couple other thoughts. This is a lot more than just paper. These methods can apply to simulation of a wide variety of temporal and spatial length scales. Through the exascale computing project, there will be more uses like the one that you saw before at ever greater scales. Here are 4 other examples of projects that are underway currently at LBL that bring together people, software, and industrial manufacturing problems to save energy and speed clean energy deployment. One is in additive manufacturing, another is in non-cryogenic separation, another is in reducing greenhouse and toxic gases from semiconductor manufacture, and the last is trying to develop a 5x boost in lithium batteries. And I wanted to close just by saying that there are a lot of ways to collaborate in HPC, and I know that mostly this talk was about the uses of HPC, but I hope this conversation goes forward in whatever directions it can to share, whether it's people, software, or systems. Thank you very much.
David Skinner, thank you so much for that wonderful presentation and slides. So next we will hear from Dr. Jeff Roberts from Lawrence Livermore National Lab. Again, Jeff helped launch this high-performance computing program for manufacturing, And it's really a pleasure to have you, Jeff, and to share with us the benefits for industry of using these tools and collaborating in this space. Thank you, Jeff. Go ahead.
Thank you very much. Good day, everyone. I was really glad to hear of the interest in adopting high-performance computing and applying it to industry problems. The program that we created, and David Skinner is a part of that, and some nice examples, will provide a background and context for you as you move forward. So hopefully we'll look at this program and you can learn from some of the things we learned and adopt it more quickly. The program is called High Performance Computing for Energy Innovation, and there are 4 pillars currently. The one we talk about the most, because it's the most mature, is manufacturing. This one over here on the left. There's also high performance computing for mobility and transportation systems, for materials and materials at extreme conditions, and also a very important topic that's being developed now is subsurface. The acknowledgement that you all know already is that in the US, the DOE, Department of Energy labs, have some of the top computational systems in the world and broad expertise in their application. But the realization was that companies struggle to stay current, and very few small to medium companies use HP. In fact, we found that there was a disconnect. They know HPC is out there, they would like to try it, but they don't really know how to get started. So we created the program with our partner labs, Oak Ridge and Lawrence Berkeley, with Livermore, to introduce the power of high-performance computing to industry at relatively low risk. It's low risk because the Department of Energy pays the national lab researcher to work on the industry problem. So it's a relatively low entry cost. And what are the benefits? The benefits really, if you look at the bottom line, they are all to enhance economic competitiveness of these companies. And how do they do that? By using the high-performance computing solutions and approach, you can accelerate innovation, get new products optimized and designed more quickly. You can lower the energy cost of producing those products. You can reduce the number of expensive tests that one must do on a product before you put it in market, especially in a critical industry like aviation. You can reduce waste and rejected parts, thereby saving the embedded energy in that process. You can pre-qualify parts, shorten the time to market. And again, these are all to enhance the economic competitiveness of the companies. The program, it was started in early 2015 in earnest, and we have had 4 solicitations so far. There is an expanding technical portfolio. We have about 50 projects right now, 26 different industrial partners. The icons of the companies are shown here. And we have a 2017 solicitation underway. One of the key components of this program is the companies have a direct link to subject matter experts and the computational resource at the national laboratories. We actually pay one of the staff PIs to interact with the company to help create a proposal that is focused and on target and can do something meaningful for the budget. And there's a high probability of success when we do that. So that's one of the big lessons we learned, is that actually matching the company to the right lab and the right practitioner of high performance computing is a key component. And now I want to give one example. Thank you, David, for the examples you gave. This one is Vitro Glass. Now, Vitro Glass was a company, a business unit that was owned by PPG and was recently acquired by a Mexican company. So it is now a Mexican-owned glass manufacturer. So I thought that was an interesting example, and they've just finished up their project, and there's some really good impacts. What was their need? They needed to optimize the process and the operation on the floor, plant floor, like David Skinner said. And they had to do a better job of production, use less energy. They have a model, but the model they had took a week or 2 to run on the cluster. And it's hard to see, but in the lower right, there's a graphical user interface of some of the components and parameters that the floor operator has. So they would change those sliders and change those parameters for the furnace and the feedstock and so on and so forth. It would take a long time for them to understand how the model would behave to those changes and stabilize. So what did our team do? We took this fully validated model, we did some statistical analysis, and data analytics and machine learning is going to be a big part of our program going forward, and they produced a reduced order model. This model now, if you change those sliders and parameters, you can do it on a laptop on the factory floor, and it takes 10 seconds. So the operator now has a tool that's validated and has the right physics in it that will help him optimize this process. The impacts are big for this one sector. When this is implemented, it'll save about 2 weeks of production per year per furnace, increase productivity by 2%, and that is, we figured out that's tens of millions of dollars of product. I don't have the exact number, it's in my notes here. And industry-wide, it's another important point, it'll save 2.5 terabillion BTUs of energy and also avoid 130,000 metric tons of CO2. So working with this company on a one-year project, a modest amount of funding, it really helped them. And all of those company logos and icons have a similar story. And I'd like to have the opportunity to talk about our experiences and good practices and move forward. Thank you.
Wow, that's very impressive, Jeff. Congratulations on that fantastic program with HPC for manufacturing, which I understand is open for international companies or foreign companies to join, correct?
That the current program that the DOE funds is open to companies that have a manufacturing footprint in the U.S. and foreign ownership is allowed in some cases, and there's a set of rules that the U.S. government goes through. So Vitroglass was allowed because they are manufacturing. That plant is in the U.S. and still doing it.
Okay, well, another reason to develop those tools in Mexico. So thank you so much. So now let me remind our viewers and participants to submit your questions through the chat feature. We will try to get to those, and if not, we will follow up on any questions we receive. So in the meantime, I will start asking some questions while we wait for your feedback. And let me ask Carlos Ortiz, again from the Ministry of Energy of Mexico, to elaborate a little bit more on what's going on in Mexico, in particular this event coming up in September. Carlos, you mentioned that Mexico is leading the Mission Innovation Challenge on materials. The global initiative is to accelerate energy innovation, and we heard a lot about that, and I think HPC and supercomputing is one of the very important tools to actually do that. And I should emphasize again that Mexico is leading this innovation challenge in partnership as co-leaders with the U.S., with the Department of Energy in the U.S., who have been fantastic partners. And we are holding this workshop in Mexico that I would like to, Carlos, if you can say a word or two on that and on this workshop on supercomputing. Let me also mention that for this workshop in Mexico, for materials, we have also another great collaboration, international collaboration with the Canadian Institute for Advanced Research, CIFAR. And so I'll ask a few questions on international collaborations in a minute, but Carlos, maybe you want to say a word or two on those two workshops on materials and supercomputing, please, and invite participation to that. Thank you.
Absolutely, Hermann. So to those, to all of those that don't know what Mission Innovation is a platform where 22 countries in the European Union have agreed to double our investments in clean tech R&D in order to accelerate the pace of innovation. Within Mission Innovation, these participating countries discussed heavily on the innovation challenges that we should be promoting in order to accelerate what we want to achieve. We chose jointly, the 22 countries, 7 innovation challenges. that are seen as the biggest opportunities to accelerate innovation. One of those innovation challenges was proposed by Mexico, working on top of the work of several scientists, amongst them Alana Spurugusic, a Mexican scientist in Harvard University, that is trying to address the question on how do we accelerate the development of new energy materials? How do we get from a simulation or a theoretical model to a material in product that will make energy technologies more efficient and more affordable? The goal of this workshop is to understand the key priority research areas that we need to work with in collaboration with the other countries in order to make this goal happen and accelerate discovery materials by an order of magnitude in the time that it takes from simulation to product. The workshop will be happening in Mexico. We'll be hosting around 60 researchers from around the world. From Mexico, US, Canada, all around, and we'll be discussing throughout 4 days what are these priorities and how do we accomplish this goal. One of the key pillars to achieving this is associated to supercomputing. How can we simulate the materials faster? How do we use machine learning techniques to continuously adapt the algorithms that are simulating the molecules and getting there faster? The other workshop that we're having is the supercomputing workshop. We will be inviting every stakeholder in the country that has anything to do with supercomputing. So from universities, I see that people from the Red Mexicana de Supercomputo have joined. We will be inviting every single member of this network. We finally achieved obtaining the membership list. Institutions, government institutions from the energy sector. So a very wide array of stakeholders. We'll be hosting a series of conferences in the morning to set the tone, create a common understanding on what supercomputing is, and then we'll use the afternoon to work with the national labs in Mexico to draft a high-level roadmap on how do we get there. How do we balance people, applications, machine? How do we best invest our resources, both time and economic, to going from where we are at the moment to a robust and fully operational supercomputing center in Mexico that is adding value to the sector. Both workshops will be held within the Future of Energy Dialogues event that the Secretary of Energy of Mexico is hosting in Mexico in September 11, 12, and 13 in Centro Santa Fe. These two are not the only events. There's a lot happening in this DEMEX event, so I invite everyone to join us. We'll have the Mexico Renewable Energy Conference with the International Renewable Energy Congress. We'll having a World Energy Leaders Summit with the World Energy Congress. We're also having an additional mission innovation workshop with the World Economic Forum, bridging academia and private sector, and many other events. So it's going to be a massive undertaking with around 3,000 guests, and it will be the happening point for energy in those dates.
Thank you very much, Carlos. So I just sent, for all the viewers, I sent the website to this Energy Summit, so you can click on it and see it. I'll share the site to the Materials Innovation Challenge in a minute. But let me ask Dr. Simon, you mentioned the ecosystem of innovations in your remarks, and I would like to ask you for to expand a little bit on the importance of international collaboration. I know you know very well another of the leaders in the field, Mateo Valero, the director of the Barcelona Supercomputing Center, who will also be at our workshop in Mexico. So maybe if I can ask you to say a few words again on the ecosystem of innovation that fits into all these events and initiatives that Carlos just mentioned in mission innovation as well, and as Carlos mentioned, we're making an effort to bring industry into this. So we'll have the World Economic Forum joining us in Mexico as part of all these efforts. So please, what are the keys to build this ecosystem, and any lessons learned, any advice you have? And of course, we don't have a lot of time. This is to key up the discussion that will continue in Mexico. Thank you.
Yeah, thank you, Herman. I think to elaborate on this topic, the theme ecosystem a bit more, high-performance computing, supercomputing really is not just a big computer. And I think this is very important to keep this in mind. By ecosystem, I mean the high-performance computer itself is necessary, but not sufficient yet to actually guarantee success. It is required to have trained people who actually understand how to use such a system. That is the trained applications user base. But it's also important to build around the knowledge about how to operate and run such a system. It is important to create a community which includes industry, university, vendors, and it is important, as I think the speakers, Jeff Roberts and David Skinner said, to have the software and the expertise to run this. So it is very difficult to bootstrap such a system. And I would say, I would caution, and I have made this point several times to Mexican colleagues, it is not really, the problem is not solved by simply spending a large amount of money putting a big computer somewhere and say, go. This has been shown to be the wrong approach and actually a failure. For example, in some instances in the United States where individual states have built such a big center, and to say very bluntly, it's very good for politicians to take a picture next to a big box and then move on to the next project. But that does not create a lasting structure that really helps both industry and science in a country. So what Carlos Ortiz is planning to do in terms of building this roadmap is incredibly important, because I think we need to have a plan to not just introduce the hardware, but also introduce the system, the networking, the people, the human capital, to elevate all boats and make a successful system of high-performance computing and create this in Mexico. And I think this will be the important goal of the workshop that will happen on September 12th in Mexico City that was already being discussed. And I, again, want to reiterate, it is important for all stakeholders to be present and participate in this, because it is not just waiting for a big thing to arrive, it is a community building effort.
If I could reinforce that in a small way, the machines come and go over time. It's nice that we give supercomputers, names and all that, but it really is the ecosystem that sustains it, and sustained operation is a really important
the human factor.
All the factors that Horst said, but yeah, the machines, the hardware itself is ephemeral.
Exactly, David. Thank you. And please interrupt any speakers if you want to pitch in. If I may ask David to elaborate on your presentation, I thought you showed some very impressive benefits for industry. I read savings of 240 to 400 million per year in savings, right? Benefits to industry. Let's direct the profits for that. If you could just elaborate on in terms of how industry can collaborate with, for example, your lab here at the Supercomputing Lab in Lawrence Berkeley, while we see this executed in Mexico, and how can that fit into this effort, please?
Well, I think for industry in particular, the HPC for Energy Innovation recipe, the model that Jeff and other folks at Livermore have helped build, is a reproducible sort of model for sure. When it comes to how many hundreds of millions of dollars are saved, I went to Berkeley chemistry, not Berkeley Business School, so I may not be the best person to answer that. But what I can say is that it's very, very encouraging to see not just one company, but a consortium across an entire industry recognize that the big, hot, expensive machine in their factory might need an upgrade sometime in the future, and to see those stakeholders come together to then use shared reproducible models of science to make a good decision about that. So
thank you, and I would like to emphasize again, this applies, you showed the example of paper and pulp, which is an important industry in Mexico. Jeff spoke about the glass industry, actually owned by a Mexican company, and so essentially can substantially benefit from using these tools today. And so that's very important to bring the stakeholders at the table and to have their interest and support. So we hope to see them on September 12th. If I may ask Jeff to elaborate a little bit on this topic, you also showed very impressive numbers, a 2% increase in productivity, incredible savings in terms of also getting faster to market, better quality products, again, reduced cost, accelerated innovation, and what's not to like. I want to just, again, if you want to add something to that, Jeff, and I want to emphasize one point, or one data point that you mentioned, Jeff, that is very important to keep in mind, which is the impact in terms of greenhouse gas emission reductions of all this. Obviously, you save energy, you reduce emissions, and we have very ambitious targets about that in Mexico and around the world to meet the Paris Agreement goals and the reduction on emissions. So, and CO2 particularly that you mentioned, Jeff, I'm not sure if you want to add a little bit on the cost savings to industry, Jeff, or anything else that David and the other panelists mentioned, please.
Yeah, sure. Exactly right. The benefit of the product, 2% is relatively modest, and it's worth tens of millions of dollars. But the savings in energy is worth something like $80 million. And if you put a price on carbon, it's, again, another number that's in the tens of millions of dollars, depending on the carbon price. And that's highly valuable. But yes, there is some low-hanging fruit out there in the energy-intensive manufacturing sectors, pulp and paper, steel making, refining, petroleum industry, chemicals, where we can apply this approach to key companies in those sectors, and they can realize savings very quickly.
Thank you. Yes, $80 million per year, I understand. So that's, again, without leaving aside the benefits on emissions, there's a huge profits to be made and the low-hanging fruits here. And so we have a few more minutes before we finish. And I want to, again, go back to Carlos, if I may. Again, we're talking about a broad or a wide array of benefits, not only, again, to industry in terms of money, but very importantly on the research side and the innovation and the accelerating innovation, getting better products and new products, new materials that we may not envision right now. So this is, I want to emphasize here and ask to finish maybe panelists, and Carlos, maybe you want to start, and I would love to hear from the other panelists that we need to understand that this is a long-term effort. This is not going to happen overnight, even though there are these low-hanging fruits that can be reached today for industry. But I think I'd like to keep the long-term view in mind when we talk about innovation and accelerating innovation. This is not creating an app on your cell phone. This is hard science that has enormous benefits. Sometimes they're not really easy to see immediately. The benefit of science, of research, investing in research. I would like to just say, if you may, maybe Horst also, obviously, Carlos, start with the vision on the need for countries like Mexico to really invest, not spend, invest in our scientists, in our researchers. We heard here, I think, very important benefits, and I know CENER has this, has been remarks. Thank you very much. Maybe we can go in the same order. So Carlos and then Horst and so on.
Sorry, Herman, I didn't hear the last part of your question.
So if you want to just elaborate on this discussion and on the importance of investing in our researchers and on the long-term view of innovation, or your vision on that and NERSC vision on that, please.
Absolutely. I will be very brief. So basically, everything that we're doing is focused on a long-term perspective of what we want to achieve as energy sector and what we want to achieve through this energy reform. In the past, we've approached our energy sector as technology consumers. This has helped us maximize the output of what we can do with the energy sector, but not necessarily in terms of the associated opportunities that exist throughout the value chain, focusing exclusively on the end product, so the barrel of oil, the molecule of gas, the electricity. Through this approach, what we want to do is develop a long-term strategy where we change the ownership of what we do with our energy sector. Of course, we're focused on the end product, but we don't want to miss all the opportunities that exist throughout the value chain, providing high-level, good opportunities for employment for young engineers, scientists, not missing on the opportunity of developing industry products, services of high value throughout the value chain. And that can only be achieved migrating from one model where you're a producer and technology consumer to a model where you leverage and capitalize throughout the entire value chain. That can only be achieved on heavily investing in developing knowledge, developing talent, and with a long-term view.
Indeed. Thank you so much. So if I may ask Horst for a final remarks, I know you need to leave after this, so please feel free.
Yes.
Thank you for being here.
Thank you, Hermann. And I just want to connect directly to what Carlos just said, developing. Just to reiterate this, because it is a long-term investment to build this ecosystem, it is absolutely critical that the universities get involved in this very early on, because universities have to develop the talent, next generation of scientists and engineers who are very comfortable with computational methods, who understand modeling, who understand how to use supercomputing and high-performance computing and computing in general, and integrate this into their science and also into their engineering. We've seen some great engineering examples, but I just want to reiterate the same thing is true about for scientific applications. So this has to be a long-term partnership between all parties, all stakeholders involved, and I think that's important to always keep that in mind.
Thank you, Horst. And if you need to, I know you have another meeting. Thank you for being here. So David and Jeff, we have a question from the audience that maybe you can address in your final remarks.
About steel?
Yes. So the question is, what do you think might be the opportunity in the steel industry where energy costs and models are complex using HPC? Is it actually feasible? So if you, both of you, Jeff, David and Jeff, I know you have to say something to say about how do you do it? Is it actually, it's not easy, but it's doable. Can you elaborate?
I saw the question from the audience, and I think the short answer is yes. It depends where in the steel industry you're talking about, but HPC is a great tool for the material science, the metallurgy, the furnace modeling. Will the part crack when it cools or not? A lot of different questions there can be addressed, and Jeff has been instrumental in identifying a lot of those. In terms of maybe the last thing I would say in terms of long-term investment, as I look forward to Mexico developing this center, being stood up, and that one of the long-term collaboration models that has been successful within the United States, Europe, Canada as well, are that the staff that work at these centers can also collaborate amongst one another over long term. So we have sister center projects with Switzerland and other places where we make our centers better by working with other centers on parallel technologies. So.
Exactly right. Jeff, do you want to elaborate on the feasibility of industry using these tools, please? And anything?
Yes, please. Thank you.
Thank you.
Regarding the steelmaking industry, I hope you can still hear me. I'm having some difficulty. The steelmaking industry was one of our first projects, and it was a consortium. And for the initial project that was modest, we took 4 different models that were disconnected, and it was for the blast furnace. We were able to work on those models, have them have input and output that the different models would then use, so they were all linked. And then these codes were then put on high-performance computing platforms, and they modeled the blast furnace process. From the outcome of that very modest, quick project, they could save about $80 million a year in fuel, the coal. And then the consortium said, this is really good, we need to start doing this more. So the consortium came back, and there was a second, more in-depth project that was funded, where the consortium in the steelmaking industry put cash in. So you could tell it was really working because they were willing to take it to the next level. And I want to add, at this point, something that Horst mentioned, we're developing an ecosystem. That's absolutely right. For the steelmaking project and for many of our projects, we have students and postdocs. The students that worked on the steelmaking project, they got up to speed, worked with top scientists and the top computational platforms. And at the end of their degree, they were snatched up by industry in a minute. I wanted to hire one, but that person was gone. So it is a workforce pipeline. It's just so many good, strong components about it. It is an ecosystem, and we can't forget the people.
Exactly. Well said. Thank you so much. And yes, so it is sort of, it's very complex, but it's feasible, it's doable. It's kind of rocket science, and that's why we need to work with you guys, with the real scientists, with the kind of quote unquote rocket scientists in applied project to solve today's and tomorrow's big challenges. So I think there's another question from the audience, whether this tool, the National Supercomputing Center in Mexico wants to develop, would be available to the community. The short answer is, of course, it's a national effort for the benefit of everybody in Mexico and collaborating internationally. So another comment is about the importance of STEM education. Jeff, David, Horst, everybody mentioned students, of course. And it doesn't start in college, it starts earlier on. So we need to invest more in education and scientific education and STEM. That's part of the reason to have this type of meetings, webinars, workshops, and national efforts. So with that, I will want to give, if Carlos is still available and wants to say the final words, but I want to really thank our panelists. This is fantastic. This is, again, to key up the discussion that we will continue on September 12th in the Supercomputing Workshop in Mexico, as well as in the Materials Innovation Challenge Workshop from September 11th to the 14th. Carlos, final words. Thank you, everybody. And we'll finish with Carlos. We will make this video available later this week for all who those who registered. Please share it, distribute it with your contacts, and thank you very much, everybody, for joining. Carlos, any final words, please?
Thank you. Just want to say that we are stepping on the shoulders of giants with the collaboration with the University of California, LBNL, with Horst, Mateo, Barcelona Supercomputing Center. We're making this goal very feasible and digestible. We will be leveraging all the existing capability and expertise that is in Mexico. We know you guys are out there. We want your opinion. We want you to work on this. And again, reiterate our big thank you to Horst, to the University of California for this cooperation that has been proven over and over very fruitful. Thank you.
Exactly. Thank you again, Lawrence Berkeley National Lab. Our friend Alberto Diaz, who's sitting here next to me, he's the architect of this webinar. He helped us set it up. Thank you very much, Alberto, for your partnership.
Thank you, Alberto.
Jeff, thank you so much. Carlos, and of course, everyone. Carlos Lopez, thank you.
Thank you all.
Bye-bye.